we're going to use both points. Let's say we start from the left. We pick the left points. Because this is the same as saying m is equal to y2. We do not know y2 yet. Let's say we have we know y1 is 2 minus 2 all over x1. We know x1 is just 1. And then we know our first value that we are going to test is 0.9999. So now before we get the slope, we need to compute the value of our function at the value of 0.999. So we have f of 0.9999. This will give us our y2. We already have the points. We just need a value of our function at that point. So f of 0.999 is equal to 2 times 0.9999 squared. This should give us the value of our function. So if we plug that into a calculator, we see that 0.9999 squared times 2 is 1.9996. This is the value of our function. This is y2. So this tells us that m is equal to, this is 1.9996. Tells us that m is equal to 1.9996 minus 2 is negative 0.0004. Since we're using 4 significant figures, the 4 decimal place after the comma, 4 decimal place after the comma. So you have to keep that consistency. So that's what we got. But then we also have to compute the bottom. We see 0.9999 minus 1 is minus 0.0001. And we see these negatives cancel. And we have that the slope is 4 at our point P1, comma 2. This is from the left side. This is from the left. This was the left side. This was the left side. So we have the left side. The slope at the left side is 4. But that's just one side. As we said earlier, we said that's not enough to convince us that, well, remember we're squeezing it from left and right, so we must test both sides. Like we showed previously, we said we must approach it from both sides. Said so we did the left side, and we see as we approach it from the left as 0.999, the slope is at 4. But we must also approach it from the right in order for us to squeeze it between those two values, both left and right. So we go back and we first want to get the value of our function. We first want to get the value of our function at the value of our function at this value. So we're testing the left side now, the right side now, excuse me. So f of 1.0001 is equal to 2 times 1.0001 squared. And this is equal to, if we get a calculator and see 1.0001 squared times 2, we get 2.0004. And if we use our equation where we have m is equal to y2 minus y1 all over x2 minus x1, apply that m is equal to 2.0004. This is the value of our function. The value of our function which is y2. The value of our function. So we see that minus 2 all over, and our x2 value is 1.0001 minus 1. So if we do the subtraction, we have 0.0004 all over 0.0001. And we see these values are the same. This is the same value we had here and the same value we have here. So that means that the slope is equal to 4. So we see that if we're approaching our point from the left and from the right, we seems to be approaching the same slope from both sides. This tells us that the slope at our point must be also the same value as those two that we're approaching from both sides. So since this is also 4, this tells us that the slope here must be 4. So if this is 4 and this is 4, this must be 4 also. And that is how we get, this is for just a note that this is the hard way. This is really the hard way. This is like, I don't want to do this every time I have to analyze an instant to find a rate of change, how something is changing at an instant. That's why we had a business, and somehow we got a function of our business, how we the profits and our revenue over the whole year, and we have a function, and it's a curve, and we want to know, like, okay, in December, or let's say in December, at that instant, right, and we have a graph of our function that is month, that we have is month versus revenue plot. So we want to see at December, right, how fast was our profits increasing? At what rate were we making money? So I don't want to go through this process every time to do, like, okay, since we're at December, we want to go to December, let's say a day after December and a day before December, and we want to see or let's say we were specific, and we was like, let's say December 15, and we gotta go to December 16, December 14. It's not a very good way to go about it, because you can have so many points on a curve. But just as a note, this is the hard way, and we're gonna see how this is connected to the limit. So in the limiting situation, we see that this is the limit. Let me see if I can find the page. We'll see that the value we approach, that is the limit. That is the limit in value. So as we was approaching from the left, we were approaching our point from the left and from the right, we see the value that we was approaching from both sides. We was approaching a limit. And that limit is said to be the slope at that point. So this is where the idea of the limit comes in, and we have the limit as x, because we took different x's. We took we had x equal 1.0001, and we have x equals 0.9999. So as our value of x approaches 1, which is the point, so when we say the limit as x approaches 1, we mean that x is approaching 1 from the left, and x is approaching 1 from the right. So if we just write the limit as x approaches 1, we mean it's approaching it from both sides, which is the left and the right. So the limit as x approaches 1. So we will have y2 minus y1 all over x2 minus x1. So we can say, here we can say, x2 approaches x1. But we know x1, ooh, we know x1 is our value, our point that we had. X1 is just the value of our point, and then y1 is also the value of the function at our point. Jeez, this is getting real shaky. So this is just 1, our point 1, and this is the value of our function at 1, which was 2. So we can also write the limit as x. Instead of saying x2, we can just replace it with x approaches 1, right, of our function, say 2x squared minus 2 all over x minus 1. We could have said x2, it's the same, but since we only have one x, we just said x. And this is how we do the limit. So instead of picking points greater than and less than, we can just compute the limit as x approaches 1. And we also see that if we just plug 1 into this equation, this function becomes undefined. It becomes undefined. So we do not compute the limit. So the first thing in solving for the limit, we want to test if the function that we have here is going to accept the value we are approaching. So in this equation, the first step we would have done, we would have tried to substitute 1 for x everywhere in this equation. But we see if we do that, we get undefined. The function becomes undefined. So we do not go about it like that. And that is the idea of the limit. So we put the function here because the function can take any value. The function can take any value as it approaches from both sides. As it approaches from left or right. As we saw, we had like 2.004 and we have 1.9996. The function can take different values. And I'm going to introduce you to the limit. I'm not going to get into a lot of the limit. I'm going to solve this using the limit rule. I'm going to solve this using the limit, just to expose you to the limit. So just to double check that we get the same value. So previously we had 4. When we did this, we got 4 as the slope at 1. So we use the limit. We said we could take the limit of this function. We could say the limit as x approaches 1. So we can simplify, like we can factor out 2 because we have 2 here, we have 2 here. We factor out 2 and we have x2 minus 1, x squared minus 1 all over x minus 1. And we see, and then we test it again. We see if we can plug 1 in. Can we substitute 1 for this value? Have we simplified enough? No, it's still undefined. So we go again. We try to simplify more. So we write the limit again. 1. And then we see we can factor. We can factor out these terms. So it's x minus 1 and x plus 1. So when we do that, the x minus 1 at the bottom and the top cancels. So these cancels, and we're left with the limit. We're left with the limit as x approaches 1 of 2x plus 1. And then we see, can we like substitute x for 1 and see if this value is not undefined? And we see yes, we could plug in 1 and we get, so once you do the substitution, you could drop the limit. You could drop that limit symbol. And you could just write 2 times 1 because we're substituting the value. And then we get 4.